We got a wagon wheel that's constructed as shown in the figure. The radius of the wheel is 0.3 meters, and the rim has a mass of 1.4 kilograms. Each of the 8 spokes lie along a diameter and are 0.3 meters long and has a mass of 0.28 kilograms. What is the moment of inertia of the wheel about an axis through its center and perpendicular to the plane of the wheel? Okay, now, on page, remember I said a minute ago there's several equations, a series of equations you use for moment of inertia. Remember, moment of inertia is the sum of all the moments of inertia of an object. On page 286, we have several equations. So now I'm not going to make you regurgitate all of those, but we'll talk about what we need to remember on that here in a little bit. Probably just these two we cover. But on page, this is what, number 33, page 296. Okay. So if you look on page 286, you see the equations for moment of inertia. Okay. All right. So notice we have a wagon wheel. So we have a wagon wheel, and it has how many spokes? 1, 2, 3, 4, 5, 6, 7, 8. That's close enough. All right. And then it has, of course, the rim is fairly thin. Okay. Around it. Okay. Then it wants to know what? It wants to know the rim, the mass of the rim. Mass of the rim is 1.4 kilograms. And the mass, let's see, the diameter of this thing, let's see now, hang on, let's read this right now. The spokes lie along a diameter and are 0.3 meters long. So from here to here, from here to here is 0.3 meters. So that's the radius, R. 0.3 meters, okay? Okay, now the spoke mass, M for the spoke, SP is what? 0.28, okay, kilograms, okay? All right, now it says, what is the moment of inertia of the wheel about an axis through its center? Okay. All right, now look, what does that mean? All right. Axis through its center. All right, here's the wheel. Rotating that way. Axis through its center, right there. Okay. If you look on page 286, you see an equation that fits that perfectly. All right? Look at equation G, thin-walled hollow cylinder. The moment of inertia for a cylinder, a thin wall cylinder, is mr squared. Okay? Then it says, through its cylinder, perpendicular, and then it says, and perpendicular to the plane of the wheel. So what is the moment of inertia of the wheel about an axis through its center and perpendicular to the plane of the wheel? Okay? The plane of the wheel, yeah. Okay, so that's the solid cylinder. The plane of a wheel. Oh, no, excuse me, not the solid cylinder. Plane of a wheel. Okay? All right, let's look at those equations and let's see which one would fit that. Now remember, a spoke is a rod, right?
Is that not just saying that it runs through the center and it's about perpendicular, like you said?
Yes. 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 No. No. Because it's not a thin wall cylinder, it's a rod. So you've got to take into account the rods. So you got your rods in your spoke. All right, here's your spokes. All right, here's the wheel right here. Here's your spokes. There's the whole wheel. Perpendicular. okay? It's a rod, okay? And notice where it's at. It's through the center, and the rod's at the center, okay? All right, look at those equations on 286, and you will see this equation right here. Moment of inertia for a slender rod. I'm just going to say rod, and it says axis at end. At end. So that's equal to 1/3 ml squared. Now L is the same thing as R. Okay. All right, so we've got to do the sum of both of these calculations. All right. Now if I give you a moment of inertia equation, everybody listen now. If I give you a moment of inertia problem on the test, it's going to be this one right here. It's going to be one very similar to this, okay? Very similar. All right, so here we go. So let's just plug everything in. Now it's just plug and chug. So we got 1.4 kilograms times what? 0.3 squared. And we get a moment of inertia of 0.126 kilograms meters squared now. Don't forget it's meters squared. For the rod, now hang on a minute. How many rods are there? Very good, 8. So you got to multiply 8 times 1/3 times 0.28 kilograms times what? 0.3. That didn't change. Squared. And you get an answer of 0.67. Notice it's not very much. And that's kilograms meters squared. Now we've got to do the what? Remember, the moment of inertia is equal to the sum of all the masses times the radii squared. So we got to add them all up. So add up, and that's what? 0.126 plus 0.067, and we get an answer of what? I total is equal to 0.193 kilograms meters squared. Okay? So that's that problem. That's a moment of inertia problem. Okay? Any questions?
Well, we need to know all the
No, I'm not going to make you memorize all of those. Just be familiar with the these two equations, okay? Be familiar with them. We're going to talk about the formula card too. How we're going to do that. Either y'all going to use yours or use mine, okay? And we'll talk about that in a minute. Okay? Any questions? See, that's fairly easy. The biggest thing is reading understanding how to read it like it always is. That's always the thing with these problems. But then picking out the right equations. But I mean, it's kind of obvious if you look at a wheel, the rim is real thin, and then the rods and where the axis is at the rod. Okay. Okay.